So let us look at this question 5. We are still looking at logarithmic equations. We need to show that log of x base 8 is equal to 2 out of 3 log base 4 of x. So the idea here, you need to look at this. From here we have log base 8, but here we have log base 4, meaning we must find a way of changing this to log base 4, and we know that to change this to log base 4 we do it this way: base 4 x up, and here log base 4 and 8 which was down. So from here we have obtained the log base 4 of x. But now how can we manipulate this? We need to get rid of this, and I think you can see the only base which can help us get rid of log base 4 8 is when you introduce log base 2, because you can see here I can write 2 power 3, and here I can write 2 power 2, and when you look at the 2 and the 3, that means there's something here we need to adjust. So this is going to be written as log base 4x. Then down here I'm going to introduce a log base 2. So I'll write log base 2 8 over log base 2 4. Yeah, this is the left hand side. We are manipulating the left hand side. So when you look at that, our log base 8x will now be equal to log base 2 8 over, now it is log base 4 x divided by the log base 2. Now what I'm going to do is now to change the 8 into prime factors. Here we have 2 power 3, so we shall get 2 power 3 here over, write it this way, there of this, so over log base 2. Now the 4 can also be changed as 2 power 2, so this will give us log base 4 of x divided by, now this is going to be a 3 because you can put a 3 here, then log base 2 of 2, and that is a 1 over, now even this 2 can be brought here, we write 2 log base 2 of 2, and this gives us this, remember this is log base 8 of x, so this will give us log base 4 of x divided by, now we have 3 times 1 which is 3, and we have 2 times 1 which is a 2. From the laws of logarithm, this is a 1. So now we can now introduce a multiplication, and now the 2 will come up, 3 down, so we get 2 over 3 log base 4 of x, hence shown or as required. So now we need to do the second part. There is a word hence. This word hence means we need to use what we have got to solve or to evaluate what is given afterwards. So we need to evaluate this. Now can we compare? Now when you look at this is log base 8 of 6. That means x is going to be equal to 6 from here. So if we are to work out this, now let us look at the nth part. We need to evaluate log base 8 of 6. Now when you compare with what we have, if you compare with log base 8 of x, it implies that x is equal to 6. Now there is another thing here, that if log base 4 of 3 is equal to this, meaning we need to create this log base 4 somewhere and we substitute for this. So we can do that. Let's see. So this will be, if I substitute log base 8x is equal to 2 over 3. Now I'm going to use x as 6. So I'll get log base 8 of 6. It will be equal to 2 out of 3 log base 4 of 6 if my x is 6. So now you can see that from here you can create a log 4 3, because this 3 can be written as log base 4 of 2 times the 3. Okay, so now from here you can see that this is going to be 2 out of 3, then log base 4 of 2 plus log base 4 of 3, and this can be substituted now, and we know that this is going to be, let us see, this is 2 out of 3, then inside here we have log base 4 of 3, which is given, which is going to be 0.7925, then plus, now what is this log of base 4? 2 and 4 are connected. We can write this as log base 4 of 4 power half, because a half is a root. So this will be 2 out of 3 of 0.7925 plus a half, then log 4 of 4, which will be equal to 2 out of 3 0.7925 plus, now log base 4 of 4 is 1. Now, much as I said that don't use a calculator at this point, since we have applied the necessary laws of logarithm, we can now come and we use a calculator here by substituting by this. We feed this in a calculator. This is 2 out of 3 of 1.7925. So this will give us, so this is 1 to 1. Sorry about that. This is a half times 1. So this is going to be a half, not 1, meaning that this is going to be a half of 2 over 3 of 0.5 plus 0.7925. So the answer here, let me press the calculator. I have 0.862. We are told to fill decimal places as the answer. Log base 6 of 4, if you compare with log base 6 of x, x is 4, then log 3, 2 is given in the question. So we need to create it. We need to create a log base 3 of 2 and we substitute for it. So now by comparison we see that x is equal to 4. So we shall come and we find our log base 6 of 4 as, by substituting, we shall get log base 3 of x, and our x is taken to be 4 now, over 1 plus log base 3 of 2. We don't have any problem in the denominator because we have a log base 3 of 2 as 0.631. But now up there we can write this as log base 3 of 2 squared. This one I want to create the log base 3 of 2. So here I'll be having 1 plus the log base 3 of 2 is 0.631. So this will give us, now these two can come down, we get 2 log base 3 of 2 over 1 plus 0.631. So now you can see that now we have got this 2 times the log base 3 of 2, which is 2 times 0.631 as it was given in the question, then over 1 plus 0. Or let me just write the answer. It will be 1.631, and that is log base 6 of 4. So our log base 6 of 4 will be this in the calculator. Now the calculator can come in because we have already applied the laws of logarithm as it was required. So here the calculator can now save us, much as here we are restricted. What they don't want you to do is now to press this direct in calculator without showing this working. So let us see from the calculator I'm getting 0.774 to 3 significant figures, and now that part is also done. So let us go to part C. In part C we have log base x of 5 plus 4 log base 5 of x equal to 4. Now the question is, we have different bases here. What should we do? Should we create the log base 5, or we make this to be the log base x? Now remember we are solving for x, so we cannot make x the base. Let us get rid of x to be the base. Now we can introduce log base 5 here. We leave this as it is, so this will be log base 5 of 5 over log base 5 of x plus, now this is going to be log x to power 4, or I can leave it as it is. This is going to be 4 log base x and log base 5 of x equaling to 4. So now you can see log base 5 of x is common. We can replace it with any other letter, so we can let log base 5 of x to be a certain letter. Let that letter be y, and this is 1, so we have 1 over y plus 4y equal to 4. And now you see something interesting coming in. If I multiply with y throughout, I'll be having 1 plus 4y squared equal to 4y. And now you can say quadratic equation of 4y minus, this is y squared minus 4y plus 1 equal to 0. You can solve a quadratic equation now. So let me use the formula. I have a equal to 4, I have b equal to negative 4, I have a c equal to 1. So here I'll be having my y as negative b from the quadratic formula, negative b, that is 4, then plus or minus the square root of b squared is 16, then minus 4a minus 4a c. This is going to be 1. Then that divided by 2 times a, which is 8. And you can see that our y is going to be, the root is 0, the square root of 0 is 0. So we just have 4 over 8. It is just a half. Since b squared minus 4ac is equal to 0, we just have only one root. Okay, so now from that, we need to come back and find x. Remember, we had the log of base 5x equal to y, and our y now is 0.5. So eliminate or find the antilog of 5 of log base 5 on both sides. Then we shall be having x equal to this 5 go the other side as a base to power 0.5. So x is equal to 5 power a half, and x is equal to the square root of 5 as the answer. That is x. We shall be taking the positive answer here. Okay, so that is part C. We have 3 more parts to go. Let us do part D. Now part D says, solve for x in this equation. You can see that we are solving for x, but now the x is a base here, so get rid of that straight away. We have log base 4 of x squared minus 6 log base x of 4 minus 1 equal to 0. So we need to get rid of this x from the base. So we can just, now because this is a 4 and here there is a log base 4, we can just take the reciprocal, and there is a law of logarithm which states that if we have the log of base a b, this is the same as 1 over log, we interchange, and this becomes the b and this becomes the a. So we can now find the reciprocal. We get 1 over, but now these two will interchange, so implying that this will be log base 4 x, let me put the 2 here, then minus 6 over, now this is going to be log of base 4x, then minus 1 equal to 0. And now you can easily see that our log base 4x is common here. I can let it to be a given letter. Let t represent log base 4 of x. So we shall get 2t, because this is twice log base 4 of x, so 2t minus 6 over t, then minus 1 equal to 0. Multiply with the t throughout, we get 2t squared minus t, then minus 6 equal to 0. So we can use factorization if it can work, or we can use the formula to get the value of t. So let us use the formula. So if we are to use the formula here, our a is going to be 2, our b is going to be negative 1, and our c is going to be t as negative b, which is 1, plus or minus the square root of b squared, which is 1, then minus 4ac minus 4 2 and negative 6, then over 2a, that is 4, 2 times 2. And now our t is going to be 1 plus or minus root 1 minus 49, we get minus 48, which is 49, then over 4. So t is either 1 plus 7 over 4 or 1 minus 7 over 4. So our t is going to be 2, or our t is going to be, this is negative 6 over 4, which is negative 3 over 2. We don't stop there because we have t equal to that log of base 4 of x, and we are interested in getting x. So that means that log base 4 of x is equal to 2. So x can be, finding the antilog of log base 4, we shall get 4 squared. So x giving us 16. Or let us see, if we take the log base 4 x will be equal to negative 1.5. It means that we shall be having our x as 4 power negative 3 by 2. So this will give us
The now question 4 came from UNEB 2011 paper 1 question 1 and say,
so we shall get 4 power negative 1.5, which is 1 over 8 as the answer. So that is part D. Now let us go to part E of the same question. Now part E, we have log of base 25 for x squared equal to log base 5 of 3 minus x squared. Now when you look at this, we can introduce log base 5 on this side so that we have log base 5 throughout. And because this is 25, it should give you a hint on how to change the base. So this is going to be log 4x squared base 5 over log base 5, then this will be 5 squared equaling to log base 5 of 3 minus x squared. So you can now see that this is going to be a 2. So we shall get log base 5. Now here I'm going to write 2x squared because I want to drop this power. So, and remember, taking note that this x is the one squared, 4 was not squared. That's why I've made 2x and I put the power on the 2 and x. So now I can now bring this 2 here. So this is going to be a 2 equaling to log base 5 of 3 minus x squared. When this 2 drops here, it will cancel with this 2 which is down. So I have log base 5 of 2x divided by 2 equaling to log base 5 of 3 minus x squared. So you can now see that these 2 can cancel with that, and now the logarithms are the same basis, so we can equate. So when we equate, we get 2x equaling to 3 minus x squared, or x squared plus 2x minus 3 is equal to 0. And you can now solve the value of x straight away. So you can see that our a is 1, our b is 2, and our c is negative 3. So we can get x equal to negative 2 plus or minus the square root of b squared is 4 minus 4ac, 4a is 1 negative 3, then over 2 times a. This gives us negative 2 plus or minus, now 4 minus minus 12, that is 16. So root 16 is 4 divided by 2. So our x is either negative 2 plus 4, which is 2, next is negative 2, which is 2, divided by 2 is 1, or x will be equal to negative 2, negative 4. We get negative 8 divided by 2, which is negative, now this is negative 6, then divided by 2 is negative 3. And now we come and we check is the yes, because now x is squared, so this will be positive. So these are the two values of x, because what we need to avoid is having a negative base, so a negative logarithm. Like now when you look at here, we shall have 3 minus x squared, which is 3 minus 9, giving us a negative. Logarithm of a negative number doesn't exist, so we shall take x to be equal to 1. So let us look at the last part of the question. If log base 2 of x plus log base 4 of x plus log base 16 of x is equal to 21 out of 16. So now there is something interesting here. Different bases, but you can see 2, 4 and 6. This should give you a hint that you need log base 2, because 2 is a common factor. Here we can get here 2 squared, we can get here 2 power 4, and we end up simplifying it if we introduce log base 2. I'm going to leave this, then I'll introduce log base 2 on this and this. So this is log base 2 of x plus, now this will be log base 2 of x divided by log base 2 of 4, which is 2 squared. So I bring a 2 here, plus log base 2 of x over log base 2 of 16, which is 2 to power 4, then I bring a 4 this side, equal to 21 out of 16. And you can see the log base 2 is common, log base 2 of x is common, so here I'll be having 1 plus 1 out of 2, because this is log base 2 of 2 is 1. Even here we get 1 out of 4, equaling to 21 out of 16. So I have log base 2 of x. Now from here we're gonna have 7 over 4, so we get 7 out of 4, equaling to 21 out of 16. So log base 2 of x will be equal to 21 out of 16 times 4 out of 7, which is 3 out of 4. Now we can eliminate the log, so x will be equal to 2 power 0.75. So our x is going to be equal to, we get 1.6818, and the value of x, and that is the question 5. So the next video is going to be on solving simultaneous equation which involve logarithm. So hope this video is helpful. Please, if you need any private coaching, it could be online via Zoom, one-on-one, so you can find me on this contact and we do some mathematics We can even do some physics and chemistry. So thank you.